students, now we are going to discuss power lost in bearing. Power lost in bearing. So there are basically two types of bearing which we are going to use. Another first is called bush bearing, and second is collar and footstep bearing. Okay, so we are going to discuss one by one. So first of all, bush bearing. Now we are going to find out power loss in bush bearing. So see here, this is bush surface. Okay, and this is length, and this is dia. Okay, and this while is there, and this is the direction of rotation. Okay, so there is while. So when shaft starts rotating, there will be viscous resistance, or we can call it as frictional resistance. Anyone, viscous resistance or frictional resistance. When shaft starts rotating, there will be viscous resistance produced by while. Okay, because it starts rotating and it is filled with the while, so there will be viscous resistance produced by the while. Now, this is to overcome this resistance. We have to overcome, or we have to reduce this one. This is not good because it will affect the movement of the shaft. Okay, so to overcome this resistance, what we are going to do, see here, power or torque or power is used. That means we are going to find out torque or power to overcome this problem. Okay, when the shaft starts rotating, there will be viscous resistance produced by the while. Now, to overcome this problem or this resistance, torque or power is used. That means torque and power calculation, torque or power calculation we have to find out. So that is why it will consume, that is frictional resistance will consume some energy, power. So how much energy is going to use by that fluid, that we are going to calculate in this class. Okay, so here, see here, first of all, we know Newton's law of viscosity is tau is equal to mu du by dy. Okay, so it is nothing but mu u by, gap between this is b. Okay, here that is b. Clearance, we can call it as clearance between bush surface and this bearing. Okay, now tau is equal to mu du by dy. So mu u by b, general profile we are considering. So this is shear stress. So force will be, force or resistance, it is called resistance, will be tau into area. Okay, so tau into area is pi d. Okay, this is, see here, pi d into L, that is area. So it is mu V by B into pi dl. This is force. Okay. Now, what we have to find out? We have to find out the torque. So, torque is equal to force into radius. So, it will have mu V, okay, that is also we can call it as force into R is equal to d by 2. Okay. So, mu V into pi dl by B into, that is radius is nothing but d by 2. So, it is mu V pi mu V d square L by 2B. Okay. Now, this is the torque. Now, this torque, we have already found out shear stress, then force into radius is torque. So, now this is the equation for, so power will be nothing but 2 pi nt by 60,000, whereas this should be in Newton meter and this should be in root RPM, revolution per minute. So, knowing this torque T, that is pi mu V d square into L by 2B, and how much power is required? Torque and power is required to overcome this frictional, okay, resistance. That is why we are finding out the torque. So, torque will be pi mu V d square L by 2B and power will be nothing but 2 pi nt. So, 2 pi nt by 60,000 when n is in RPM, revolution per minute, and torque is Newton meter. So, by this way we can find out the power lost in bush bearing. Okay. So, there are two types of bearing, bush bearing and color bearing and footstep bearing. So, bush bearing uses this one. So, when it starts rotating, there will be frictional resistance created by the fluid or oil inside the bearing, okay, bearing and outer surface of the bush. So, that power or torque has to overcome this frictional resistance, okay. So, produced by the oil, to overcome this resistance, torque or power is used. So, what is that equation? Torque will be equal to mu into du by dy. So, it is linear profile. So, u by, that is V by B, okay. So, that is frictional resistance is shear stress into area is pi d into L. So, mu V by B into pi dl. So, that is force, and torque is force into resistance F into d by 2. So, mu V pi into d, L into d by 2, and this is the torque. Here also we can put V is equal to omega into R, okay. So, if you put that value also, that equation will change, it is angular velocity, okay. So, total velocity will be angular velocity into radius. So, we have to put here value, if we put the value V is equal to omega into R, that equation will be different. But anyway, if you put that one, that also we can do that one, that is not very difficult job. See here, this torque will be equal to mu pi V is equal to omega into R, okay, or R is equal to d by 2, okay. So, here see R is equal to d by 2, so it is omega into d by 2. So, all the terms are d, so better to put in terms of R only. So, this one V is equal to omega into d by 2. So, omega into V is equal to omega into R. So, R is equal to d by 2, okay. Now, we have converted this into d square into L by another 2b, okay. So, it is nothing but pi mu omega dql by 4b, okay. So, this equation torque, and knowing this torque, applying this torque here in 2 pi nt, it will give you the power loss in bush bearing. And color and footstep bearing power loss, that I will discuss in next class. Thank you.